Hello everyone, and welcome to your video tutorial over an Atwood machine. There are two variations of an Atwood machine. Basically, what it is you have a mass connected to a pulley connected to another mass, and you can have an Atwood machine like this, or you can have one like this, where your masses are both hanging down, and this is fixed to, a structure or the ceiling or something like that. And what we're going to do is I'm just going to differentiate these as M1, M2, M1, and M2. Okay, so if I look at this variation, let's look at number 1 first. And I'm going to say that this is a frictionless surface. Okay, well, the system, if this is frictionless, well, if we look at the free body diagram for M2, I've got its weight, which is M2G, and I've also got its tension force. Well, that tension force in the string is connected through this pulley, which means it is also over here. And so since this is frictionless, there's no force to slow it down. There's no force to counter this tension force. Now, M1 has its weight, which is M1G, and it has its normal force, but with this type of problem, M1 isn't just going to all of a sudden jump off the table because this tension force is pulling it horizontally. So normal force and M1's weight cancel each other out, so they don't contribute to the overall net force. Okay, so if you think about it, the net force for the system, imagine if I sort of drew it kind of like this. Here's M1 connected to M2, and here I have M2G, which is the weight. Looking at it like that, that M2G is the net force, because that's the only force that's pulling in this direction, to the right. Yeah, there's tension force here, but there's also tension force here, and they cancel each other out. Okay, so applying Newton's second law, the sum of my forces equals my mass times my acceleration. And for this block, M2, my net force is M2G. That's the only force that contributes to the overall acceleration. Now, my mass is the entire system. It's M1 plus M2. Because if I look at this drawing, this representation of my Atwood, yeah, I'm pulling it this way, but I'm pulling both blocks. So it's like they're one block in a sense. So the acceleration is M2G over M1 plus M2. So looking at that, if I increase M2, okay, then my acceleration overall gets bigger because I'm adding more mass to this system, to this hanging block here. Because I'm taking that mass and I'm multiplying it by 9.8 or 10 or whatever gravity is. If I add mass to M1, I'm adding mass in the denominator, more and more mass. So adding mass in the denominator actually lowers the acceleration, which is to be expected. So let's put some numbers in here. Let's say I've got a 2 kilogram block and then a 4 kilogram block. It's a frictionless surface, and I want to know, let's say I want to know the tension in the rope. Okay, well, to do that, I have to know the acceleration. So we apply Newton's second law. And here, my net force is, again, this block's weight. So I go mg, which is 4, times gravity, which we'll just use as 10, so 4 times 10, equals the mass of the entire system. 4 plus 2 gives me 6, times my acceleration. So 4 times 10 gives me 40, equals 6a. So dividing by 6, let's see, that would give me, let's just go 20 over 3 meters per second squared. Okay, now, I noticed that some of you today were confused about the sign. That acceleration, the way I solved for it, that's the magnitude of the acceleration. So if you think this block, well, it's accelerating down, so this acceleration would be negative. This block is accelerating to the right, so we would associate that as positive. If we were dealing with this block specifically, then I would make this weight negative because it's directed down. And so that would make this negative, which would make this negative. So that's for the hanging mass. Okay, now, but the question was, what is this force due to tension? Well, I'm going to apply Newton's second law, but I'm going to do it specifically for the hanging mass. Now, the sum of my forces, well, that is tension plus the force due to gravity. That equals the mass of that particular block, which is 4, times the acceleration, which is negative 20 over 3. Well, I know the weight, it's negative 40, because that's mg. So I could plug in negative 40, minus 40 equals 4 times negative 20 over 3. And then you just add 40 to the, multiply, add 40 to the other side, and you have tension. So that is for this configuration, for configuration 1. Now let's look at the second configuration. I have M1 and I have M2. And so let's just say that M2 is greater than M1. In other words, I have a net force that's directed down. So this block is accelerating up, or excuse me, down, and then this block over here, M1, is accelerating up. They both would have the same acceleration because they're connected through the rope, or through the string. So just like how we drew this with this kind of configuration here, we can do the same thing here. So imagine M2 and M1 connected like this. This block M2 has its weight vector going this way, which is M2G. This block has its weight vector also pulling down, but here in this situation it's pulling this way. So do you see how they're kind of working against each other? So the net force, the sum of my forces would equal the mass times the acceleration. And I told you the net force is the net mass times gravity, and that equals the mass of the system times the acceleration. Because look, if I subtract these two, if I sum my forces in a sense here, the x direction, well, yeah, there's tension here, but just like before, they cancel each other out. So this would be M2G minus M1G, which if I factor out a G, that's where I get net mass. And that equals the mass of the system. Okay. So, let's do configuration 2, but let's put some numbers into it. Let's say that, let's do the same thing. I've got a 2 kilogram mass and I've got a 4 kilogram mass. Obviously, I'm going to be accelerating down. So in a sense, this is M2, it's 4 kilos. This is M1, and it's 2 kilos. Okay, the net force Again, starting with Newton's second law. You guys seeing a pattern here? Starting with Newton's second law. It's kind of a boom, 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 boom. Kind of an important deal. Okay. My net force, that would be the net mass, which is 2 times gravity. That equals the mass of the system, which is 6 times the acceleration of the system. So here I've got 2 times gravity, which is 20. That equals 6 times A. Okay? So, I would have 20 over 6, which would be 10 thirds equals A. So you see how the acceleration is different than over here. It's the same 2 blocks, but over here with configuration 1, this block is resting on a surface. Here, M1 is hanging. Okay? So that's how you figure out the acceleration of each block. They might also ask you for the tension, and you would do the exact same thing. Apply Newton's second law, and you pick a block, either block 1 or block 2. And you go, sum of my forces for block 2, that would be Ft plus Fg, and that would equal M2. Now, the acceleration of block 2 is down, so this would be negative 10 over 3. So this would be Ft minus its weight, which is 4 times 10, so 40. Its mass is 4 times negative 10 over 3. Add 40 to the other side. Bada bing, bada boom. So that is a brief review over Atwood's machines.